Hello everyone, my name is Utsav Basu. My roll number is 20CS30057. For this week's DIY project, I have made a circuit which represents a car which stops automatically when it senses an obstacle in front of it. So let us see the circuit. So the first breadboard is connected to an Arduino Uno and an ultrasonic sensor. The trigger pin and the echo pin are connected to pin numbers 3 and 4 as we can see. Whenever the echo pin registers an obstacle which is resistance less than a certain threshold value, which in this case is set to 150 centimeters, then the voltage at pin number 7 is set to high. That is, it sends a signal through this pin. The signal released from pin 7 is visualized by a voltmeter and an oscilloscope that are connected in parallel to this connection. This signal is further fed into the second breadboard, as we can see here, which is connected to a motor which represents the wheel of the car, an NPN transistor and a 9-volt battery. The NPN transistor is connected such that it acts like a switch. Whenever it senses the signal from the pink wire, it acts like an open switch, and for the rest of the time, it acts like a short circuit. As a result, using the transistor, we can control the motion of the motor. There is an ammeter and a voltmeter connected in series and in parallel to the motor respectively. It basically helps to visualize the current that is flowing through the motor and the potential difference across its ends. Let us look into the code now. So here's the code. Firstly, I've declared three constants representing the trigger pin, the echo pin and the signal pin. Then the setup function starts the serial monitor and initializes the various pins to their respective modes. I've also used the built-in LED in the Arduino board, which is this one. This is the built-in LED to make it easier to visualize if the signal is correctly released or not. Now in the loop function, this part of the code represents the detection of an obstacle if it is present or not. The duration variable measures the time in microseconds which the pulse that is released from the ultrasonic sensor takes to bounce back from the obstacle. Then the distance is calculated using this formula and is printed into the serial monitor. Further, if the distance of the obstacle is less than 150 centimeters, then the signal pin is set to high and the built-in LED is lit up. Otherwise, the signal pin is set to low and the built-in LED is turned off. So let us see the working of the circuit now. So here's our circuit. Let me start the simulation, and here we are. As we can see, since the distance of the obstacle is represented by this blue dot is greater than 150 centimeters, we can see that the motor is rotating very fast at about 1060 rpm. Now if we bring the obstacle such that its distance is less than 150 centimeters, then the motor starts rotating at only about 7 rpm, which is a drastic decrease in the rotation speed. Thus the wheel of the car basically does not move at all. and hence it stops. The signal can be visualized using the voltmeter and the oscilloscope, as we can see here. Both of them register the signal perfectly. In addition to that, we can see that the built-in LED does light up when the obstacle is less than 150 centimeters from the car and turns off when it is further away. Now to look at the serial monitor, we can see that indeed the distance is printed out in the serial monitor. So that is all. Thank you very much.